Opie works at a factory that produces a special type of washer. A sample of 400 washers has a diameter of 10.05 centimeters with a standard deviation of 0.1 centimeters. Produce a 95% confidence interval for the diameter of a washer, giving your answers in centimeters to 2 decimal places. Well, first of all, we can say that x bar is going to be normal with 10.05 and 0.1 squared over 400, which of course means that the standard deviation is 0.1 over the square root of 400, which of course is 20, and that is 0.05. Having stated that, I'm now just going to go for the confidence interval. And of course, I have an E activity that will do that for me. So I am going to go into the menu, into the activity, and I've got the confidence interval for a mean just here. And I need to put in the mean, which is 10.05. 10.05. The next thing that I need to put in is the standard deviation. And the standard deviation is 0.1. We don't adjust that at all here. The next thing is the n, which is 400 in this case. And then we want the confidence interval, which in this case is 0.95. And once we've got all those things in there, we'll just run it. And we will get 10.04 to 10.06. The next day, Opie takes another sample of 400 washers. Is the following statement true or false? Give reasons. The mean for this sample will lie within the confidence interval from part A. That is false. It's a new sample, and natural variation means no guarantee. It lies in first confidence interval. Remember, this is a 95% confidence interval. We're only 95% certain, or at least 95% of such confidence intervals will contain the true mean. If we knew that the actual distribution of the diameters was not normal, would this invalidate the confidence interval in part A? And explain. No. Large N of 400 means that the central limit theorem applies and the sample means would be normal, or at least normally distributed. Okay. Another sample of 100 washers is taken. It is found that the mean is 10.01 centimeters, the standard deviation is 0.15 centimeters, and the confidence interval calculated is this one here. What is the confidence level? Okay, so we know for this particular sample that it's normally distributed 10.01, 0.15 squared over 100, which means, of course, that sigma is 0.15 over 10, which is 0.015. Now, we can use either the top or the bottom. We know that So that's the bottom of the interval. If I do 10.01 and I subtract the standard error, which is going to be Z, I'm not sure which Z, so it's going to be Z times the standard deviation of 0.015, that has got to be equal to 9.987. Remember, we're doing the middle, take away the standard error. However, we can just use the E-activity to do this, so you can find it from here. We could use the E-activity though. So if we use the sample n for the confidence interval, we know the n in this case is 100. We're going to be trying to work out the Z level. The sigma is 0.15. Remember, we use an unadjusted figure there. And the E is going to be 10.01 take away 9.987. We'll solve that for Z and we get 1.53. So Z is equal to 1.53 recurring. And then we go to Z score for CI, the 1.53 recurring is in there. We want the confidence level and we just do that and we get 87.5%.